Hello students, good day to all. It's Yusuf sir again with the next video of lines and angles. So in this video we are going to solve exercise 6.3. In the previous video we have solved exercise 6.2 and in this video along with exercise 6.3 we are also going to solve two more theorems on angle sum property of triangles. Now let us start our today's session. Now let me start with the angle sum property of triangles. It has two theorems. Let me state it for you people. So theorem number 6.7 says the sum of all the angles of a triangle is 180 degree. The theorem says if a triangle is there, all the angle sum it is equal to 180 degree. One more second theorem, what does it say? 6.8, it says that if a side of a triangle is produced, then the exterior angle so formed is equal to the sum of two interior opposite angles. So these two theorems will prove it one by one. So let's move for the theorem number 6.7. What does it say? So it states that the sum of all the angles of a triangle is equal to 180 degree is 180 degree. So this theorem we are going to prove it. Now let us assume that there is a triangle, say PQR. If you just observe in the figure, there are three angles, 1, 2 and 3. Okay, so these are the three angles we have got in a triangle. So we need to prove that their sum is again equal to 180 degree. So how we are going to prove it? So let us start proving the theorem. So let us assume that what PQR is a triangle. So this is the given thing which we have got. We are assuming ourselves. Okay, so what we are going to prove? All the three angles, these three angles, 1 angle 2 angle 3, their sum it is equal to 180 degree. So let us write that one. So to prove that angle 1 plus angle 2 plus angle 3 it is equal to 180 degrees. So now you need to prove. So how you are going to prove? So to prove that one construction we are going to do. What is that construction? So draw XPY parallel to QR such that XY passes through P. So you have to draw one line XY such that it should pass from point P. So that XY become parallel to QR. Okay, so let us draw that one. So we have drawn it. If you just see the figure, XY is parallel to QR and it is passing from P. Now let us go for the proof part. So let us give these two angles as angle 4 and angle 5. Okay, so let us go for the proof part. From the figure it is been observed that what we can see that if you see that these three angles, angle 4, angle 1 and angle 5, whether they are becoming a linear pair, because XY is a straight line. If all the adjacent angles will become so their sum will become equal to 180 degrees. So let us write that one. Okay, so let us write that one. What we are observing, we can see that angle 4 plus angle 1 plus angle 5 it is equal to 180 degree because it is a linear pair. Okay, now if you just observe, we have taken one by construction, we have got XY is parallel to QR. So XPY it is parallel to QR means so where PR and QR become transversal lines. Just observe, if these two are parallel, they are cutting these two parallel lines, means PR and this PQ and PR will become transversal lines. Let us write that one. What we are going to write? XPY parallel to QR and PQ and PR are transversals. We have written that PQ and PR are transversal. Now if you just observe, if they are transversal lines, just observe this. Here also you are going to get alternate angle 4 equal to 2 and one more pair it is there, this angle 5 it is equal to angle 3. Why? When their two lines are parallel, then alternate angles are always equal. So we are going to write angle 4 it is equal to angle 2 and angle 5 it is equal to angle 3, pair of alternate angles. Now we have got this angle 4 it is equal to 2 and angle 5 it is equal to 3. Now we are going to substitute these values in equation 1. Let us substitute that. Substituting the value of angle 4 and angle 5. we know that angle 4 is equal to angle 2. and angle phi it is equal to angle 3. If you substitute those values here, what will happen? We are going to get in place of 4 angle 2, in place of phi angle 3 we are going to get. Just when you substitute that one in 1, we are going to get angle 1 plus 2 plus angle 3, that is equal to 180 degree. That is what the all the sum it is equal to 180 degrees. This is the proof for the theorem. So hence the sum of all the angles of a triangle is equal to 180 degrees. This is the proof for the theorem. Now let's move for the theorem number 6.8. It is most interesting theorem. Now what does that theorem state? If a side of a triangle is produced, then the exterior angle so formed is equal to the sum of two interior opposite angles. Now what does this mean? So let me show you with an diagram first. So here we have got this. Let us take one triangle with angle 1, 2, 3. So what it is saying, if you draw one line or extend one side of a triangle, the angle which is formed exterior, means this angle which is formed at the exterior side, it is always equal to the sum of two interior opposite angles. Now which are the two interior opposite angles? Angle 2 and angle 3 will be two interior opposite angles. Now this is the adjacent angle, these are two opposite angles. So interior opposite angles will be 2 and 3. So we are going to show that one. Okay, so let us prove this one. So let us assume that PQR is a triangle. We have taken it. So we need to prove that angle 1, see, angle 1 we are not going to take it here. Say angle 4. Now which is the angle 4 here? This will become angle 4. Which one? Which is at the exterior. Now angle 4 is at the exterior. Which is at this will become angle 4. This should be equal to angle 2 plus angle 3. Okay, so one construction we are going to do, at produce line QP till S. So let us produce it. Now I have extended this line. Okay, so this will become S, point S. Now when it is extended, this will become angle 4. Okay, so now we have got angle 4. Okay, what we need to show, this angle 4 it is equal to angle 2 plus angle 3 we are going to show. This is what the theorem it is saying. It should be equal to angle 2 plus angle 3. So that's what we are going to prove. Let us write that one to prove. Okay, we have written it. So now let us go for the proof. So in the figure, what you are observing, if you observe there, what you are going to say, one thing we are going to write, what we have just now proved, that angle 1 plus angle 2 plus angle 3 is equal to 180 degree by angle sum property, say theorem number 6.7. Let us write that one first. Okay, angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. We have written it, theorem number 6.7. Now if you just observe this QS, it is a line, and this PR it is standing on that line. Now if PR is standing on a line, that means sum of adjacent angles should be equal to 180 degree. So angle 1 plus angle 4 will also become 180 degrees. So if you just observe, RP stands on a line QPS, right? Now this is QPS is a line and RP is standing on it. So there are adjacent angle sum, it should be equal to 180 degree because it is a linear pair. Now just observe equation 1 and equation 2. Both are equal to 180 degrees. So if both are equal to 180 degrees, so can I equate them? Yes, obviously. So let us equate them, equating equation 1 and 2. Now if what you are observing, well, once you equate equation 1 and 2, the left hand side, this 1, 2, 3, it is equal to angle 1 and angle 4, sum of both. Now this one, if it goes this side, that will become negative. This one and this one will get cancelled. What is left? Angle 2 plus angle 3 it is equal to angle 4 is left. That is a proof for the theorem. So we have proved that angle 4 it is equal to sum of 2 and 3. So this is the proof of the theorem number 6.8. So these are the two theorems, important theorems from this part. So let us move for the exercise. So exercise first question it is. So first question it says, in the given figure, now this is the figure, side QP and RQ of a triangle PQR are produced to the points S and T respectively. If you just observe the figure, this PQ it is produced till S and QR it is produced till R. Now if SPR it is equal to 135 degrees, they have given one angle that is 135 degrees, and one more angle PQT it is equal to 110 degrees. Okay, we have written it. So what we need to find? We need to find angle PRQ. This angle we are going to find out. So how to find out? So let us solve the solution. Okay, given what are the things given here? We know that only it is given that what are the given things. Now let us write two angles have been given, SPR and PQT it is equal to 110 degrees. So let us write that one first. Okay, so we have written it. Now next thing what we are going to do, so SPR plus QPR, just observe SPR, this SPR and QPR, whether they are forming a linear pair. Obviously, because QS is a complete line and PR is standing on it, that means their angles should be equal, sum it should be equal to 180 degrees. So let us write that one. So SPR plus QPR it is equal to 180 degrees. It is a linear pair. Now one angle we know, what is that? SPR. We have got SPR equal to 135 degrees. So let us substitute that one in that equation. So what do we get? 135 plus QPR it is equal to 180 degrees. Now 135, if it goes this side, what happens? 180 minus 35. So 180 minus 35 it is 45 degrees. So let us write QPR it is equal to 45 degrees. So one value we have got, this QPR it is equal to 45 degrees. So we have got one angle it is equal to 45 degrees. So let's move for the next bit now. Also observe angle PQT, whether just observe this angle PQT plus angle PQR, whether it is equal to 180 degree. Yes, obviously, because this RT is also a line and PQ is standing on it, right? So PQ is standing on it, that means their adjacent angle sum is also equal to 180 degrees. So let us write that one. Also PQT plus PQR it is equal to 180 degrees. That is because linear pair. Okay, now we know one angle here. What is that? PQT. So this angle we know that. Let us substitute that value here. Now what we will get? 110 plus PQR it is equal to 180 degrees. Now what if you take this 110 degrees his side, what happens? This will become 180 minus 110, that is equal to 70 degrees. So let us write that one. What? One PQR, angle PQR it is equal to 70 degrees. This angle will become 70 degrees. Now we have got two angles. This one it is 45 degree and this one it is 70 degrees. We have got two angles now. Now we solve it by angle sum property. We have sum of all the angles, it is equal to 180 degree. We have got two angles. Can we find out the third angle? Yes, we can find out. So let us go for the next step, that is just writing. Also the sum of all the interior angles of a triangle is equal to 180 degree. Therefore we are going to write, what we are going to write? Angle QPR plus PQR plus PRQ, that is equal to 180 degree. That is PQR plus QRP plus and PRQ. These three angles you are going to get angle PQR plus PRQ plus QRP it is equal to QPR it is equal to 180 degrees. So these three angles you are going to add up. So we know two angles. Which are the two angles? This one as well as this one. This one is 70 degrees and this one it is 45 degrees. We have just found it. Okay, substituting those values. QPR it is 45 degree and PQR is 70 degree. PRQ we don't know, it is equal to 180 degrees. So we have got two values. If you add them both, you are going to get if you take that to right hand side, what it will be? It will be negative. So 45 plus 70 will become 115 degrees. If you take it to that side, what will happen? It will become minus 115. Now we are going to write that only. So PQR it is equal to 180 minus 115, that is equal to 65 degrees. That is the solution for the question number 1. Okay, now let's move for the next question. What does the next question say? Let us so in the given figure, now what is the given figure here? Let us see the figure. Okay, so this is the figure we have got. Angle X it is equal to 62 degrees. This angle they have given. And one more, angle XYZ it is equal to 54 degrees. We have got this angle as well. This angle that is equal to 54 degrees. And one more thing they have given. What they have given, this OY, YO and ZO are bisectors of what? Angle XYZ and XZY. They are the bisectors of these two angles. Bisector means they will completely divide them into two equal parts. Okay, so of triangle XYZ respectively. Now you need to find out angle OZY and angle YOZ. You are going to find out these two angles. How to find out these two angles? So what we have got, as the sum of interior angles of a triangle is 180 degree, therefore for triangle XYZ we have got these two angles we have got. This third angle can be found by angle sum property. Yes, we can find it by angle sum property. So let us write that one. So angle X plus angle XYZ plus XZY. This angle plus XYZ angle plus XZY, these three angles, if you add both all three, you are going to get 180 degrees. So we have got two angles here given. Angle X also we have got, that is here 62 degrees. Angle XYZ also we have got, that is 54 degrees. Substituting that value in the equation, we are going to get 62 degrees plus 54 plus XZY, it is equal to 180 degrees. Now if you add them both, what you are going to get, 62 plus 52, it will become 116 degrees. If you take it to this side, what it will be? 180 minus 116 it will be. So let us write that one. So XZY it is equal to 180 minus 116. So XZY it will be equal to 64 degrees. Now this is what the one angle we have got. Okay. So next we are going to find out angle OZY. How to find out angle OZY? See, OZY, this OZY, it is a half of angle XZ. Okay, XZY, it is half of XZY. So we are going to half it. So OZY it is equal to 64 divided by 2. That is equal to 32 degrees, because OZ is the angular bisector of OZY. It is completely divided into two equal parts. So how to find out the next? Similarly, can I find the OYZ? OYZ also I can get, because 54 completely XYZ it is 54 degree, half of 54 it is OYZ. So we are going to write OYZ it is equal to 54 by 2, that is equal to 27 degrees. We have got two angles in this triangle. If you take this smaller triangle, we have got two angles there. One it is 27 degree and one more it is 32 degree. Can we find the third angle by using angle sum property? Yes, we can find using angle sum property for OYZ. We obtained, so we triangle OYZ we obtained. What we are going to obtain? See, OYZ, this angle, okay, this angle plus YOZ, just observe this angle, plus OZY, whether these three angles sum it is equal to 180 degree. Yes, by angle sum property we can write that one. So we are going to write OYZ plus YOZ plus OZY, it is equal to 180 degree. We have got two angles here, OYZ as well as OZY. So we are going to substitute it. So 27, we are going to place O in place of OYZ 27 degrees, and in place of OZY we are going to place 32 degrees. So we have placed it. Now if you add that both to, how much it will be? That will be equal to 59 degrees. If you add them, it is equal to 59 degrees. If you take it to here, that will become minus 59. So YOZ it is equal to 180 minus 59 degrees. So If you subtract it, what you are going to get? Angle YOZ, it is equal to 21 degrees. Now this 121 degrees. So this is the solution for the question. Okay, now this as well as these two are the solution for the question. This completes your answer second. Now let's go to the third question. Now third question is, in the given figure, now let's see the figure. If AB is parallel to DE, now in this figure you can see that AB, it is parallel to DE. Now one more thing, they have given two angles they have given. What are those angles? BAC, it is equal to 35 degrees, and one more CDE, it is equal to 53 degrees. They have asked you to find angle DCE. This angle they have asked you to find out. Now how to find out this angle? So let's go for the solution. First we'll write what are the given things. Okay, AB is parallel to DE and AE is a transversal. Now when AB and DE are parallel and AE line is cutting both the lines, so AE will become transversal line. So whenever a transversal cut parallel lines, their alternate angles are equal. So I'll write angle BAC, it is equal to CED. So this angle, because alternate interior angles. So let us write that one. BAC, it is equal to CED, alternate interior angles. So can I write CED, it is equal to 35 degrees? Because BAC, it is equal to CED. Let us write CED, it is equal to 35 degrees, because they are alternate angles. Now in triangle CDE, just observe this triangle. We have got one angle. We have found this one angle. Okay. Now one more angle they have given. By applying angle sum property, can we find the third angle? Yes, obviously we can find. So let us apply it. So in triangle CDE, angle CDE, this angle plus angle CED plus angle DCE, it is equal to 180 degree. Let us write that one. We have written it, CDE plus CED plus DCE, it is equal to 180 degree. Now in place of CDE, we have got the values. CDE also we have, that is 53 degrees. CED we have got it here. Only thing which is left is this one. So let us substitute the values of CDE and CED. 53 plus 35 degree plus DCE, it is equal to 180 degree. If you add these both, you are going to get 88 degrees. So when you subtract it from 180, you will get 92 degrees. So let us DCE, it is equal to 180 minus 88 degrees. That will give you 92 degrees. So this is the answer for the third question. Now let's move for the fourth question. Okay, so in the fourth question, they have given that in the given figure, now let's see the figure. If line PQ and RS intersect at point T, just see the figure. PQ and RS are two lines which are intersecting at T. Okay, now such that PRT, here they have given three angles here. Which are those angles? PRT, it is equal to 40 degree. Then RPT, it is equal to 95 degree, and one more angle they are given, that TSQ, it is equal to 75 degrees. They have asked us to find out angle SQ. Which one there? SQT they have asked. So okay, this angle you are going to find it out. Now how you are going to find it out? By, if you just see the figure here, you can see that there are two triangles they are being formed. Okay, in first triangle you can see that there are two angles. Third angle we can find it by applying angle sum property. Let us apply. Okay, let's go for the solution. Using angle sum property of triangle P, for triangle PRT, we obtain what are the, how we can apply? So angle PRT plus RPT plus PTR, it is equal to 180 degree. These two values we have, PRT and RPT we have, they are given. Now let us substitute those values. So what you will get, 40 plus 95 plus PTR, it is equal to 180 degrees you are going to get. So when you add this 40 plus 95, it will become 135. When you subtract it from 180 degrees, you are going to get PTR, it is equal to 180 minus 135, that will be equal to 45 degrees. So answer for this, it is 45 degrees. This angle it is equal to PTR, it is equal to 45 degrees. Third angle we have got. Just observe that PQ and RS are intersecting lines. If they are intersecting lines, then their vertically opposite angles are also equal. So can I write PTR it is equal to STQ? Can I write that one? Yes, we can write, because STQ it is equal to PQR vertically opposite angles, that is equal to 45 degrees. So STQ angle we can write it as it is equal to 45 degrees. So let us write that one. Okay, we have written STQ it is equal to 45 degrees. Now just observe the second figure. Now STQ also we have got, and one more TSQ we are also knowing the value of TSQ. So one more we need to angle we need to find out, that is SQT. This angle we are going to find out. Again we can apply angle sum property here. So by using angle sum property for triangle STQ, we get, now what we can write, STQ, angle STQ plus SQT plus, we can also write TSQ or QST. You can write you can take QST or TSQ, both are equal. So let us write that one. It is equal to 180 degrees. So I written, we note two angles here. One is QTS or STQ, and one more this angle and QST we know. QST and STQ we know. Let us substitute those values here. So 45 plus SQT plus 75 degree, it is equal to 180 degree. If we add 45 plus 75, that will be equal to 120 degrees. So when you take it to right hand side, what happens? SQT it is equal to 180 degree minus 120 degrees you will get. So that will be equal to 60 degrees. So this is the solution for the fourth question. Okay, so let's move for the next question. So fifth question is, in the given figure, now just observe the figure. Now in the given figure, PQ is perpendicular to PS. Perpendicular to PS means they are at 90 degrees. Okay, now PQ is parallel to ST. So we have written it, and they have given two angles, that is SQR it is equal to 28 degrees, and one more QRT that is equal to 65 degrees they have given. So now they are asking you to find out the value of X and Y. So let us go one by one. So can we use, just observe here, PQ is parallel to SR, or you can take ST. Okay, PQ if it is parallel to SR, then QR becomes a transversal line. It is cutting two parallel lines. You can just observe that for these two parallel lines, this line is cutting. If this line is cutting, then you are going to see that their alternate angles are equal. So can I write alternate angles are equal there? So let us begin with the first step. What? PQ is parallel to SR given, and QR is transversal. If it is a transversal line, then can we write PQR it is equal to QRT? So let us write. Why? Reason alternate interior angles. So this angle it is equal to this angle. Why? They are alternate interior angles. So if they are alternate interior angles, just observe angle PQR. It is a combination of two angles, X plus 28 degrees. In place of PQR I'll write X plus 28, and in place of QRT I'll write 65 degrees, because it is equal to 65 degrees. So let us write that one. PQR it is equal to X plus 28 degrees, and QRT it is equal to 65 degrees. So X it is equal to 65 minus 28, that is equal to 37 degrees. We have got the value of X here. Now we have got the value of X. Now just observe, we have got this angle, and we know this angle that is equal to 90 degrees. Why? Because they are perpendicular. So can we apply their angle sum property? So let us apply. By using the angle sum property of triangle, for triangle SPQ, we obtain, what we are going to obtain? Just observe, angle SPQ plus angle plus X plus angle Y, it is equal to 180 degree, because sum of three angles of a triangle it is equal to 180 degree. So let us write that one. SPQ plus X plus Y it is equal to 180 degree. Two angles we know here. SPQ is 90 degree, and angle X we have found it here. So let us substitute those values in that equation. So what you will get, 90 plus 37 plus y, it is equal to 180 degrees we are going to get. So if you take these two values to this side, what will happen? 90 plus 37, it is 127 degrees. So y, it is equal to 180 minus 127. So we have got 180 minus 127. So what will be the answer? Y, it is equal to 53 degrees. So we have got both the values, x equal to 37 and y equal to 53 degrees. So let us write both the values here, x equal to 37 degrees and y equal to 53 degrees. Now this is the solution for fifth question. So let us move for the last question. Okay, so in the last question they have given us to prove something. What is that? In the given figure, just see the figure, the side QR, now this side there is a triangle PQR. QR is extended or produced to point S. They have been extended and produced to S. If the bisectors of angle PQR, now this is angle PQR and this is bisector of angle PQR, and one more, bisector of PRS, and this angle it is PRS and this is the bisector of PRS. So they are meeting at point T. The bisector of both the angles, angle PQR and PRS, the bisectors, they are meeting at point T. What do you mean by bisector? The line which bisect that angle into two equal parts. That is angular bisector. Okay. Now you need to prove that QTR, it is equal to half QPR. You need to show that QTR, it is equal to half. Just a second. So we need to show that QTR, it is equal to half QPR. Now this QTR, this one, QTR, it is equal to half QPR. Now this is half of this angle. Now we have to prove it. Okay, so how to prove it? So let us begin our proof. So let us write what we are going to see in the for the triangle QTR. Just observe triangle QTR. Just this is a triangle QTR. Now TRS, this TRS angle, now this TRS angle will become exterior angle. In this theorem number 6.8, we have studied that exterior angle, when you produce one side of a triangle, the exterior angle, it is equal to the sum of two interior angles. So this exterior angle, it is equal to sum of two interior angles. So that's what we are going to write it here using that theorem. Okay, so angle QTR plus TQR, it is equal to TRS. What? QTR plus TQR, it is equal to TRS. The exterior angle, it is equal to sum of two interior angles. Let us write that one. What? QTR plus TQR, it is equal to TRS. Next, what we are going to write? Just we are going to take this TQR to the right hand side. What it will happen? So TRS minus TQR, it is equal to QRT you are going to get. So QRT, it is equal to TRS minus TQR. We are giving it as equation 1. Why? We are going to use it again. Okay. So now let's go for the one more triangle it is there. So which is the triangle? For triangle PQR. Now for triangle PQR, PRS will become exterior angle and two interior angles will be QPR and PQR. Okay. So two interior angles will be PQR and one more QPR. So let us write that one. Okay. So for triangle PQR, PRS is exterior angle. So we can write QPR plus PQR, it is equal to PRS. And now for the next step, we know that these are bisectors, angular bisectors. So they are dividing that angle PQR and PRS into two equal parts. If they are divided into two equal parts, can I write PQR, it is equal to 2 TQR, because both are equal. This TQR, it is equal to TQP. So I will write PQR, it is equal to 2 TQR. Next, one more, PRS, it is equal to 2 TRS. I will write twice the TRS. So let us write that one. Okay, QPR, this QPR plus, in place of PQR we are going to write 2 TQR. Why? Because if you double it, you are going to get this complete angle 1. That's why we are going to write TQR. Okay, for similarly for PRS we have written twice the TRS. Okay, so because QT and RT are angle bisectors, okay, we have written the reason. Now just observe. Now what we will do, we will take this 2 TQR to right hand side. What it will happen? It will be minus 2 TQR. Okay, so 2 TRS minus 2 TQR. Now let us take 2 common. Okay, so 2 TRS minus TQR you are going to get. So QPR it is equal to 2 common we have taken, TRS minus TQR we are going to get. Okay, so now in place of TRS and TQR, what you are going to do? We are going to substitute this value. So just see the equation 1. TRS minus TQR it is equal to QTR. So in place of this value we are going to write QTR. So let us write that one. So QPR it is equal to 2QTR. So using equation 1. Now just take this 2 to the this side, you are going to get in a denominator. So QTR it is equal to half QPR. That is a proof. Hence proved. This completes your exercise as well as the chapter. Thank you.